Okay, so physics quiz 1 is parallax, 2 is precision, 3 is accuracy, 4 is significant digits, 5 is before, 6 is after, and that was our newer ones, questions about 1 to 6.
If they got significant but they didn't get digits, is that half?
Yeah, I'll go half.
I put values, didn't I?
Significant figures also would work. Anything 1 to 6.
Oh, number 6 they just put multiply.
No, that doesn't make sense. We were trying to do either before or after. Top 6. 7's Galileo. 8, pick anything that we talked about with him. If you recognize the fact, just give the point. If you're not sure, we'll clear that up in a second. 9, we would go experiment, analysis, conclusion, and testing. I didn't tell you to put it in that order, so just let that go. But next time, let's go in that order, because testing can't be first. That'd be sort of dumb. But experiment, analysis, conclusion, testing. Powers of 10 is the convenient answer. World system is SI. The 3 units are kilograms, meters, and seconds. Derived are a combination of fundamental units. Physics is a science that examines the relationships of matter and energy. Matter and energy have to be in there. Kinematics, study of motion, science of motion, something like that about motion. Mechanics would be the study of forces and energy. If they had only one of the 2 words between forces and energy, we'd go half on that. We'll pause the record. Repeat it.
Okay.
It's fine. Okay, so the 2.9, we're reading 2.9 to 2.11. It's going to be a reading about graphing. There will be 2 points from 2.9 that should stand out pretty well. And then as you keep reading, they're going to draw you like 3 different types of graphs that all have names. So you want to be ready for those other 3 kinds of graphs that have names for me to either I draw a picture, you do a name, or I do a name, you draw a picture, something like that. So 2 points from 2.9, 3 more points as you read 10, read 11, 3 graphs you're going to see, total of 5. If you've been through trig this year, it'll be reminiscent of our second day of trig lesson. Some of those words are going to come right back at you already. Compared to today, quiz, starting from today's number 9 down, the scientific method stuff, that's all going to just stay the same. I don't see any real differences there. Number 1 is going to disappear. I'll explain it just because I'm sure it's back on the test. An example of parallax might be you're sitting in the driver's seat of your car and you can see your speedometer and you know what speed you're going. Your parent is sitting beside you looking at the same thing, but they have a different viewpoint, so they may not read it accurately. So your parents are like, "Are you driving 68 miles an hour?" You're like, "No, I'm not driving 68 miles an hour. I'm driving 78 miles an hour." They can't quite see it right. That's an example of parallax, that if you have a different positioning, things can sort of shift on you. That's not a super important thing, so that question didn't come back. Precision goes backward. Precision is an instrument's exactness. Accuracy is basically, this is not the quiz answer, but accuracy will go backwards. If I were going to do it in a non-quiz answer, I'd say basically accuracy is something that's like your fault as the person measuring if it gets messed up. Precision, it would be like the instrument's fault if you can't measure it. But accuracy is answered tomorrow. We'll just stick with what's on the quiz, the degree of agreement between a measured and a true value. So, for example, if I were going to try to use this measuring tool and I said that something that's this long is 3.7. Is that a good idea or a bad idea? That's a bad idea. Is that a problem with precision or is that a problem with accuracy? That is a problem with accuracy. That is me messing it up. If I would say to you that that is, and this is my tool, this is all I have to go on. I try to tell you that this is like 5. Is that right? I don't know. Is that a problem with accuracy or precision? Precision, because that was the instrument's problem. Okay, if I got out my meter stick and tried to measure something that's too big for it, like that, that's a precision idea. So that was 2 words in this. Precision is basically what can the instrument do. Accuracy is like your own fault. If I said that this is like 1.4, would you buy that?
Yep.
I'd buy that. What if I tried to say, I am positive, that's 1.4731? Would you buy that? I wouldn't buy that. There's no way we could use this tool to be precise to like that position. If I would say this is 3.8, that's stupid. 3.8 is a problem with my, which word? Accuracy. If I tried to argue this is 1.4731, I can't make that argument. Even though that might be right, I can't really argue that based on the instrument's precision. It can't, this tool can't measure that precisely. That would be not a correct move to make. Significant digits is going to go in a different format. I'll ask you to make me a list of what digits are significant. People that have been through chemistry, big advantage tilts your way. Can somebody give me one of the 4 categories of digits that are significant?
Anything other than 0?
Anything other than 0 is in the list. Any digit other than 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, for sure are counted as significant digits. Second club?
Zeros with lines over.
Zeros with lines on them, like this. Those are counted as significant digits. Somebody else a category?
0 to the right end, doesn't it?
Zeros at the right end of decimals. Zeros at the right end of decimals, by which I would mean, yes, something like this is at the right end of the decimal. No, this is not at the right end. Those don't count. 4th category?
Zeros in between 2 significant.
Zeros in between other significant digits, like this. So that 0 is trapped in between some other stuff. That 0 would count as significant. Right now, you have no idea, 11th graders, what in the world I'm probably talking about, but we'll expound on that in a minute. But 4 categories that are significant digits is anything other than 0, zeros at the right end of decimal stuff, zeros in between other significant digits, and zeros that have bars on them. More on that to come in a moment. Let's see, 5 is going to stay the same, but with an additional detail. For adding or subtracting, we're going to round beforehand. With the add-on information next quiz, use the least precise place. We're going to round beforehand, and we're going to use the least precise place. 6, we'll keep the question the same, but add on another level of detail. So you'll say for multiplying and dividing, we're going to round afterwards. And the add-on is use the fewest amount of significant digits from the problem. Use the fewest amount of significant digits from the problem. Which again, if it's the first time you're hearing this, that probably makes no sense, but we'll illuminate that by actually doing some things in a minute with significant digits. I think the rest of that then we're good. So the grand total's going 25 because we had 5 new ones. We ditched a little bit of that Galileo information and sprinkled in a little bit more detail on some other things. Question about quiz content.
What did you say went with the adding subtracting?
So adding, we're going to say beforehand and to use the least precise place. Not making the quiz, but an important idea, and maybe it should have made a quiz. If I were going to retool the quizzes tonight, I probably would add this on. Around number 4, the point of significant digits is to show you how certain you are, and the last significant digit is always uncertain. So if you want to jot that down, that may help you understand things when I'm talking in a minute. The point of significant digits is to know how certain something is. The last significant digit is always uncertain. I shouldn't have erased that so fast. If I were going to measure this, and I say that this is 1.4, how certain are we about the 1 part of that? Very certain, 100% certain. There is no doubt, if we understand how to measure, that that is 1 and some change. How sure are we about the 0.4 part? Not totally sure. That could be a 1.3. That could be a 1.4. Could that be a 1.5? No way, because 1.5 would be dead on halfway. So no way that's 1.5. But we could get in an argument about 1.4, 1.3. These are both considered significant digits, but the last digit in either one of those, we're not certain. There's always a point when you measure things that you're just not certain about it. I had to fill up this bottle the other day. I've got a line here where it's more or less 32 is where I stop. But if I'm filling water out of the faucet, am I dead certain I'm going to get exactly 32? Probably not. I might go a little bit overfill and get 32 point, a little bit more and think, yeah, close enough. Or I might be a little short at 31.9 and think, I'm not going to take my chances. Okay? It's very difficult to measure 32. So to illustrate the point, I usually use numbers like this and talk about pirate games. I used to go to pirate games back in the olden days when I was young, when things like pirate games to let the fans go. But if I go to the pirate game and you'd say to me, how many people were at the game yesterday? I could say 20,000, but I might mean a different sort of thing. Somebody that doesn't go to a lot of games might look around at a crowd at a pirate game and mean there's about 20,000 people, but they might have no idea what they were talking about. There might have been 10,000, there might have been 30,000. They're just kind of taking a guess where 20,000 is their best guess. If I write this number this way, I would be indicating to you there were 20,000 people there, but I'm really not sure about this digit even. Might have been 10,000, might have been 100,000. Like, give or take, me missing this spot by 1, that's my best guesstimate. I've gone to a lot of games, so I'd be more likely to give you an answer like this, where I'm telling you there's 20,000 people there. About how sure am I if I'm making this my last significant digit?
Within like 1,000.
Within 1,000. And I might be able to do that because I've been to a lot of games. So I might be able to tell you there were 20,000 people there, and I'm pretty firm on this 20,000. There might have been 21, there might have been 19, but I'm more sure about it if I write it this way than I am if I write it this way. If I were the person in charge of the ticket office at the park, I might be able to give you that answer, where I'm telling you I might only be off plus or minus 1 person, because now I've made the ones place be the last significant digit. Somebody counted those tickets, and somebody's very sure how many people went to that game, and that would be a way they could communicate to you 20,000 people, and I'm not off. I might have missed it by 1. Maybe 1 person sneaked by me at the gate or something. This person would be saying, we're all saying 20,000, but this person might be off by 10,000. This person might be off by 1. What if I was off by 10? I'm like, I'm pretty sure about 20,000, but I might have missed that by 10 for some reason. How would I illustrate I might be off by 10?
Mark above the 3rd 0.
A bar above the 3rd 0, because that's the tens place. If I'm like, hey, I got 20,000 of something, but I might have mismeasured by 100, that's how I could show you I might have mismeasured by 100, or I might have mismeasured by 10. Okay. All of these have 20,000 as their best answer that we could give, but they have a different degree of how sure we are. Okay, that's what significant digits are for, is to illustrate not just what you think you measured, but how sure are you about it. Question about that concept. Part of your homework then, they'll give you measurements and they'll just ask you, in this number that we're presenting to you, how many of these digits are significant? And sometimes it's all of them, sometimes it's not all of them. This would have one significant digit, only the 2. This would have 2 significant digits, the first 2. Because the rules we just read a minute ago were anything other than 0, zeros with bars on them. This has 3. Anything other than 0, zeros with bars and stuff stuck in between. This has 4. All of those. This has all 5. So in the homework, they'll give you some numbers like that and say, how many significant digits are there? Answer for this, all 3. Not a 0, zeros at the right end of decimals, and stuff stuck in between. All of those are significant. In terms of math quantity, these two things are the same. Okay, but in science explanation, this I'm saying, it's 3, but maybe not. Maybe I messed up. Maybe it's actually 3.1, or maybe this could go as high, not as 3, it might be up to 4, or down to 2. 3 is my best guess. You know, this is the kind of stuff you might say to me, like, how many A's were there on the quiz yesterday? And I'm like, I don't know, about 3. Am I firm on my 3? No, there might have been 4 or 5. There might have been 1 or 2, but like 3 is my best guess. If I would say something about 3.00, I'm very sure about that. Maybe it's like 3.01. Maybe it's 2.99. But this is the place that I'm like, I don't know. They're the same math number, but this has much more certainty to it. Count on this. 3. Not that one. That 0 is called a placeholder. I have to write it to just hold the 1's place to make that number be a number. But these are significant because they're not zeros, and then that 0 got trapped in the middle. All 5. This had a bar on it. This isn't a 0. Everything else is trapped. That is a 5-digit answer. This is me saying to you, might be 20,301, but 20,300, that's my best guess. All 5. Not a 0. 0 at the right end of a decimal. Everything else got trapped. The trapped things are sometimes called enclosed zeros. 3. Which 3 don't count? The zeros at the end are placeholders. These aren't zeros. That 0 is enclosed. We're going to count those 3. Say again? 3. Agree with 3? Which ones don't matter? The first 3 are just placeholders. Zeros at the right end of decimals count, but these are placeholding zeros. Those don't matter to anything. That has 3, not the 2 placeholders, but the other ones. So some of the homework will ask you, how many significant digits are there? That's the game that you're playing. Question about that? Okay, when you go to do math, and we have numbers to add, but we want to maintain a sense of how accurate we are with our numbers. If we had one of our measurements that's only accurate to the tenths, does it really help you in the big picture that one of your other measurements was super accurate if you have one that's more limited? It does not. Okay, so what we need to do if we're adding or subtracting is notice which number cut out first, and cut all the numbers out at that spot. And we're going to want to round them all to the same place. So if we round this to the tenths place, we come out with, round that to the tenths, round it to the tenths, 1.7. If we round this to the tenths, 2.3. That add the numbers all together. One more little thing and then we'll let you run away. if you're multiplying or dividing, you do the problem first, and this would turn out to be 1.0824. Do the math first, then do a count. How many digits is this? 3. How many digits is this? 2. The answer can only have 2. So we keep the first one, we round to the second one. If we round in this location, 1.1. The homework that's built up off of this is, where is it? 1 to 12. 1 to 12 is the homework on this. Lunchtime.